Today, we're diving deep into the heart of Apple's latest silicon masterpiece, the M4 chip. Whether you're a seasoned developer, a tech enthusiast, or just curious about what makes these chips tick, this video is for you. We'll be dissecting the M4's architecture, delving into its core technologies, and understanding how it achieves such incredible performance and efficiency. At the heart of the M4 lies a fundamental design philosophy, RISC, or Reduced Instruction Set Computing. Unlike its CISC counterparts that boast complex instructions, RISC architecture keeps things streamlined with a smaller set of simpler instructions. Think of it like this. Instead of having one complex tool that tries to do everything, you have a set of specialized tools, each optimized for a specific task. This simplicity allows the M4 to execute instructions with incredible speed and efficiency. Each instruction is streamlined for optimal execution on the processor's pipeline, reducing the time it takes to complete tasks. This leads to faster processing, smoother multitasking, and an overall snappier user experience. But it's not just about speed. The RISC architecture also plays a crucial role in the M4's impressive power efficiency. By simplifying the instruction set, Apple's engineers have minimized the complexity of the processor's control logic. This reduction in complexity translates to lower power consumption, allowing the M4 to sip power while still delivering exceptional performance. Now you might be thinking, but what about complex tasks that require those complex instructions? Well, that's where the M4's clever design comes in. It combines the simplicity of RISC with advanced techniques like superscalar execution and out-of-order execution. These techniques allow the M4 to process multiple instructions simultaneously and in an optimized order, effectively masking the limitations of a reduced instruction set. So, while the M4 might seem simple on the surface with its RISC architecture, don't let that fool you. It's a testament to the power of efficient design, squeezing every ounce of performance and battery life out of every instruction. One of the key innovations of the M4 chip is its asymmetric multi-core architecture, featuring a combination of high-performance Firestorm cores and high-efficiency Icestorm cores. This dynamic duo works in perfect harmony to deliver an optimal balance between raw power and energy efficiency. The Firestorm cores are the heavy lifters of the M4, designed to tackle demanding tasks like video editing, 3D rendering, and software compilation. These cores are built for speed, boasting a wide instruction pipeline, large caches, and advanced branch prediction capabilities. They're like the muscle cars of the processor world, ready to roar into action when performance is paramount. On the other hand, the Icestorm cores are the efficiency champions, optimized for everyday tasks like web browsing, email, and light document editing. These cores are designed to sip power, featuring a smaller footprint and lower clock speeds. Think of them as the fuel-efficient city cars of the processor world, effortlessly handling day-to-day tasks without draining your battery. But the real magic happens in how the M4 chip manages these cores. Apple's sophisticated power management system dynamically switches between the Firestorm and Icestorm cores depending on the workload. If you're just browsing the web, the M4 will primarily utilize the Icestorm cores, conserving power for when you need it most. However, fire up a demanding application, like a video editor, and the M4 seamlessly transitions to the Firestorm cores, unleashing their full processing power. This dynamic switching happens in real time, completely transparent to the user. You get the perfect blend of performance and efficiency without even lifting a finger. This intelligent use of asymmetric cores allows the M4 chip to achieve an impressive balance between power and efficiency, delivering exceptional performance when you need it while maximizing battery life for everyday tasks. Now, let's talk graphics, because the M4 chip doesn't disappoint. At the heart of its graphical prowess lies a technique called tile-based deferred rendering, or TBDR. This innovative approach to rendering graphics revolutionizes how images are drawn on your screen, leading to stunning visuals and buttery smooth performance. Traditional rendering methods, known as immediate mode rendering, process pixels one by one as they're received from the GPU. This can be inefficient, especially when dealing with complex scenes with overlapping objects. TBDR takes a smarter approach, dividing the screen into smaller tiles and rendering them independently. Think of it like painting a wall. Instead of painting one brush stroke at a time across the entire surface, TBDR is like dividing the wall into sections and painting each section completely before moving on to the next. This allows the GPU to work more efficiently, reducing redundant calculations and memory bandwidth usage. But the benefits of TBDR go beyond just efficiency. This technique also excels at handling complex lighting and shading effects. By rendering in tiles, the M4 chip can more effectively calculate lighting interactions between objects within each tile, leading to more realistic shadows, reflections, and ambient occlusion. Moreover, TBDR allows for advanced post-processing effects to be applied more efficiently. Since the scene is rendered in tiles, post-processing filters can be applied selectively to specific areas of the screen, further enhancing visual fidelity without sacrificing performance. This combination of efficiency and visual fidelity makes TBDR a game changer for mobile graphics. It allows the M4 chip to deliver console-quality visuals on a mobile device while maintaining impressive battery life. One of the key architectural innovations of the M4 chip is its Unified Memory Architecture, or UMA. This elegant solution breaks down the traditional barriers between the CPU, GPU, and neural engine, allowing them to share the same pool of memory seamlessly. This shared memory pool has profound implications for performance, efficiency, and overall system responsiveness. In traditional computer architectures, the CPU, GPU, and other processing units each have their dedicated memory spaces. This separation requires data to be copied between different memory locations, introducing latency and consuming precious power. UMA eliminates this bottleneck by providing a single unified address space for all processing units. Imagine a bustling city with separate districts for different functions. Now imagine if all those districts were merged into one interconnected hub. That's essentially what UMA does for the M4 chip. The CPU, GPU, and neural engine can now access and process data simultaneously without waiting for data transfers, leading to faster processing times and smoother multitasking. This shared memory architecture also has significant implications for power efficiency. By eliminating the need for redundant data copies and transfers, UMA reduces the overall power consumption of the chip. This means longer battery life for your devices without compromising performance. Furthermore, UMA unlocks new possibilities for developers, enabling them to create more efficient and powerful applications that leverage the full potential of the M4 chip. Developers can now easily share data between the CPU, GPU, and neural engine, leading to innovative applications in areas like machine learning, image processing, and real-time graphics rendering. The Unified Memory Architecture is a testament to Apple's commitment to pushing the boundaries of mobile computing. It's a prime example of how a seemingly simple architectural change can have a profound impact on performance, efficiency, and user experience. The M4 chip is a masterclass in power efficiency, thanks in part to a clever technique called dynamic voltage and frequency scaling, or DVFS. This dynamic power management system allows the M4 to optimize its power consumption on the fly, adjusting its voltage and frequency based on the workload demands. Think of it like driving a car. You wouldn't drive at highway speeds in a school zone, would you? Similarly, the M4 chip adjusts its performance levels based on the tasks at hand. When the workload is light, such as browsing the web or checking email, the M4 lowers its voltage and frequency, effectively putting itself into cruise control mode, sipping power and extending battery life. However, when you launch a demanding application or game, the M4 chip kicks into high gear, dynamically increasing its voltage and frequency to deliver the necessary performance. This real-time adjustment ensures that the M4 chip is always operating at the optimal balance of performance and power consumption. But DVFS is more than just a simple on-off switch. The M4 chip constantly monitors its workload and thermal conditions, making minute adjustments to its voltage and frequency in real time. This granular control allows the M4 to fine-tune its power consumption with incredible precision, squeezing every ounce of battery life without sacrificing performance. The benefits of DVFS extend beyond just battery life. By dynamically adjusting its operating parameters, the M4 chip can also reduce its overall heat generation. This is crucial for mobile devices, where excessive heat can lead to performance throttling and reduced lifespan. DVFS is a prime example of how intelligent power management can significantly impact the user experience. It's a testament to Apple's commitment to delivering devices that are both powerful and energy efficient, allowing you to do more with your devices for longer. When it comes to power management, the M4 chip takes a multifaceted approach, employing a combination of techniques to minimize power consumption. Two of these techniques, P states and C states, play a crucial role in managing power consumption, particularly when the device is idle or under light workloads. P states, or performance states, are like different gears for the processor. Each P state represents a different voltage and frequency level, allowing the M4 to scale its performance and power consumption based on the workload. When the device is idle or under light load, the M4 can transition to a lower P state, reducing its clock speed and voltage to conserve power. Think of it like dimming the lights when you leave a room. You're not turning off the lights completely, just reducing their power consumption when they're not needed at full brightness. Similarly, P states allow the M4 to dim its power consumption when it's not under heavy load. C states, or CPU states, take power management a step further by putting portions of the processor into a sleep mode when they're not in use. There are multiple C states, each with varying levels of power saving. The deeper the C state, the more power is saved, but the longer it takes to wake up the processor. Imagine this. You're at home, and you know you won't be using certain appliances for a while. You might turn off the lights completely, unplug the TV, and maybe even switch off the power strip. That's essentially what C states do for the M4 chip. They power down unused portions of the processor, minimizing power leakage and extending battery life. The M4 chip intelligently manages these P states and C states, seamlessly transitioning between them based on the workload and system activity. When you pick up your device and start using it, the M4 quickly wakes up from its low power state and resumes full performance. This intricate dance of P states and C states allows the M4 chip to maintain an optimal balance between responsiveness and power consumption. It's like having a super efficient standby mode for your processor, ensuring that your device is always ready to spring into action while minimizing battery drain. And there you have it, folks. The Apple M4 chip, a testament to Apple's relentless pursuit of innovation in the world of silicon. From its RISC architecture and asymmetric multi-core design to its unified memory architecture and advanced power management techniques, the M4 chip is a marvel of modern engineering. It's a chip that's not only incredibly powerful, but also incredibly efficient, setting a new standard for what's possible in mobile computing. If you're as blown away by the M4 chip as I am, hit that like button and subscribe to the channel for more in-depth dives into the world of tech. And don't forget to ring that notification bell so you don't miss out on future videos. We've got a lot more exciting tech to explore, so stay tuned for upcoming videos on the latest and greatest in the world of consumer electronics. As always, thank you for watching, and I'll catch you in the next one.
Subscribe it.